Hello everyone. In this video we're going to be discussing section 9.1, which begins on page 554 of your textbook. So in this section we're going to be adding and subtracting polynomials, and in the next section we'll be multiplying them. So first it's going to be helpful to get down some definitions. A monomial is a number variable or a product of a number and a variable. It could also include more than one variable. So a couple of many examples here. Example, one term would be 4x. Another monomial here would just be the number 7. It could be negative 17xyz. Those are all three examples of monomials. So a binomial is the sum or difference of two terms. So I would have two monomials. And a trinomial is the sum or difference of three terms or three monomials. So just doing one example for each, this would be something like 2x minus 7. And an example for this one would be x squared plus 2x minus 7. So there's three terms there, three different monomials that are separated with plus or minus signs. And a polynomial could be any number of terms. So a polynomial, as long as it's greater than 1, could be a binomial, 2 terms, trinomial, 3 terms, or a little bit higher, a quartic or a quintic. So we're going to carry on with a couple more definitions here. So what is a term? A term is a monomial in a polynomial, so just one of the pieces separated by a plus or minus sign. A coefficient is the number in front of a variable. So if we look at an example of that, if I had negative 17x, the coefficient here would be negative 17. Alright, so there is another more specific type of coefficient, and that is a leading coefficient, which is the coefficient of the first term. A leading coefficient is going to be arguably one of your most important coefficients in an entire polynomial. Alright, so we're going to be looking at that. So the question then becomes, how do you know if it's the first term, and what should be the first term? And we'll get to that when we talk about standard form. Alright, so a constant term is a number without a variable. So in the previous example, up above, if I had 2x minus 7, the constant term would be the negative 7. The degree of a polynomial is the greatest degree of its terms. So in order to find the degree of a polynomial, you take the degree of every single term and you add the exponents of the variables. So for example, if I had x squared minus 7x cubed plus 4x plus 1, the degree of this monomial, this term, is 2. The degree of this term is 3. The degree of this term is 1. And the degree of the constant term is always 0. So the degree of this polynomial would be 3. Alright, which would make negative 7 my leading coefficient. And that brings us to standard form, which is going to be written in decreasing order. So if I use that last example here, in order to write it in standard form, I would make sure that my leading coefficient is out in front with my degree, and then I go to x squared plus x squared, and then it would be plus 4x and plus 1. So it's in decreasing order. So I think we're ready to go ahead and look at a ton of examples. Always feel free to pause the video and work them out by yourselves, and then check with the answers. So example 1, write 15x minus x cubed plus 3 so that the exponents decrease from left to right. So that's writing it in standard form. And then identify the degree and the leading coefficient. Alright. So the solution, consider the degree of each of the polynomial's terms. So if you were just looking at it, the 15x is degree 1, since there is a 1 as the exponent. And then you've got x cubed minus x cubed, degree is 3, and then that constant is always going to be a degree 0. Alright, so rewriting it, make sure that the leading coefficient there does appear, which is a negative 1. Alright, so it's negative x cubed plus, should be 15x right here, plus 3. Alright, so the greatest degree is 3 and the leading coefficient is negative 1. Tell whether a polynomial, if it is a polynomial, find its degree and classify it by the number of terms. Alright, so if you look at these expressions, is it a polynomial? So if it is a monomial, that does make it a polynomial. Alright, looking down into row C and row D here, those are not polynomials because they don't look like anything that we've written before. They look like the exponential curves that we wrote in the last chapter. So if n is, or any variable, x, y, z, q, p, doesn't matter, if a variable is as an exponent, that is not a polynomial. And in row D here, if there's a negative exponent, that is not a polynomial. So those would be two things to mark for what to look out for that is not a polynomial. In row E here, this is the first time you're seeing two variables multiplied together. So even though there is a b and a c, and then a b and a c in the next term, but they have different exponents, that is a polynomial as well. And if you count the exponents, 7b c cubed, that's degree 4, and then the 4b to the 4th c, that is to the 5th. So that means it is a 5th degree binomial, and bi means 2 terms. Alright, so that brings us to this entire section. Find the sum. So what we need to do is we need to look at the exponents and make sure that they line up and that they are common terms here. Or like terms. So then all we need to do is add or subtract the coefficients. So find the sum. In order to find the sum, there's a couple of different ways you can do this. So we've got the vertical format, which means you're going to take the two polynomials and line them up according to exponent and degree here, and then you just add vertically. This is something similar to what we did when we were doing elimination and substitution to solving linear systems 2 chapters ago. So you would just add them together. 2 plus 1 x cubed gives you 3x cubed. Negative 5 plus 2 is negative 3x squared. And then a 1 plus a 0, and a 0 minus or plus a negative 1 gives you plus x minus 1. Alright, there is another format, however. A horizontal format allows you to group terms and then simplify from there. So you're writing left to right instead of up to down this time. So the way they write it is you can regroup it. You can put all the x squareds together, all the x's together, and then all the constants together and just add or subtract horizontally. And in this case, you end up getting a 3 plus 1 x squared, 4x squared, a 1 plus 4x, plus 5x, and a negative 6 plus 10, which gives you a plus 4. Alright, so why don't you go ahead and try this guided practice and see what you get. Write 5y minus 2y squared plus 9 so that the exponents decrease into standard order, left to right, and then identify the degree and leading coefficient. So if I were to rewrite it, I would have negative 2y squared plus 5y plus 9. So the degree is the sum of the exponents, all right, it's the highest sum of exponents in each term, so that would be y squared, so the degree is 2, and the leading coefficient of that term is negative 2. Tell whether y cubed minus 4y plus 3 is a polynomial. If it is a polynomial, find its degree and classify it by the number of terms. Otherwise, tell why it is not a polynomial. So yes, it is a polynomial. I have numerical exponents. There's no variable in the exponent, and there's no negative exponents. So this does work. It is a polynomial. It is of degree 3 because the highest degree that we have among our monomials is 3. And it is a trinomial because there are 3 terms. Alright, next guided practice, find the sum. So you could have done this horizontally or vertically, but you would have the 5x cubed plus 3x cubed to give you the 8x cubed. You would have a 4x squared just by itself, and then you would have a 4x minus 2x to give you 2x. And then you'd have a negative 6. So altogether, it has 4 terms. My degree of the polynomial is 3, and my leading coefficient is 8. So this brings us to subtracting polynomials, which is going to be, a very similar process that we've underwent before. All right, so in example 4, find the difference here. If I have 4n squared plus 5, then I subtract the entire next polynomial. And then I've got another example. So, solution. We separate our terms and we're working vertically here. So when I subtract vertically, I need to make sure to be careful and distribute that negative sign to every single term. So it'd be minus negative 2n squared minus 2n minus negative 4. Alright, and when we do so, we distribute that negative sign and then we can add vertically to get 6n squared minus 2n plus 9. Or, as they work out example 4b here, you can do it according to groups again and work horizontally. So they write it all out with distributing that negative sign. You do need to make sure to distribute that negative sign. So that became minus 3x squared plus x plus 8, changing our signs by multiplying by that negative. And then we rewrote it in groups, and then we subtracted or added to get x squared minus 2x plus 13. Degree of 2, it is a trinomial, and the leading coefficient is 1. Alright, example 5, a multi-step problem here. Let's not be afraid of word problems. Major League Baseball teams are divided into 2 leagues. During the period between 1995 and 2001, the attendance N and A in thousands at National and American League baseball games, respectively, can be modeled by N equals this polynomial, negative 488t squared plus 5,430t plus 24,700, and A equals negative 318t squared plus 3,040t plus 25,600. So, where t is the number of years, that makes sense, t for time, since 1995, so if it was 96, t would be 1, right? And if it was 2000, t would be 5. About how many people attended Major League Baseball games in 2001. So we need to make sure that T equals, and we'll find that out. Step 1. Add the models for the attendance in each league to find a model M for total attendance between the two leagues. Alright, so whether you're working vertically or horizontally, doesn't matter as long as you're adding the correct like terms here. Alright, same amount of variables, so the t-squareds go together, the t's go together, and the constants go together. And here is our final total attendance. Alright, here's our polynomial for the total attendance. And then substitute 6, since it is 2001 and that is 6 years after 1995. So into my polynomial, I substitute in 6, and I need to be very careful if I'm typing it into my calculator because I'm dealing with exponents, and my calculator is always going to work in the correct order of operations. So if I were to type this into my calculator, actually, I would have negative 806 times, and I would put this in parentheses here, 6, and whether you were using the caret like this and putting in a 2 for squared, or whether you are using this actual x squared button, right? You need to make sure that you are correctly typing all of that in. Alright, so then when we do that, we get 72,100. So about 72,100,000 people attended Major League Baseball games in 2001. The reason why that number changed is because if you look back at the problem, it does say in thousands. So whatever number we got, we needed to multiply by 1,000. So we got 72,100, and I multiply that by 1,000, adding 3 zeros onto the end. That gives me just over 7 million. Alright, so let's do a couple of guided practice. Find the difference. So go ahead, line it up horizontally or vertically, pause the video, and see if you can get what we get. Alright, so we do get 4x squared minus 5x squared for negative x squared, negative 7x minus 4x for negative 11x, and a minus negative 9, which gives me a positive 9. Alright, and then let's look at guide practice number 5. Look back at the last example with the baseball attendance and find the difference in the attendance at National and American League baseball games. So I'll go ahead and scroll back here to the two models. So find the difference. Find the difference. Pause the video and find the difference. Alright, and if you worked it out all correctly, you would be at about 7,320,000 people. Alright, so there are about 7.5 million more people that attend national baseball games versus American baseball games. Alright, if you guys have any questions, please feel free to ask by sending me an email or a message on Google Classroom.